Okay, let's continue. Uh, I won't be speaking that much anymore. I'll just keep solving. So we do have three more questions on case 2, projectile fired at an angle. And yeah, let's start. Okay, I just wanted to say that uh, the VIY going up and the VFY going down are the same value. Um, I'm I'm sure if the surface is even, but I suppose that if the surface is not even, let's say there's a shot is fired on a cliff and the ending is still all the way down, like that. Uh, as long as the like before the projectile reaches any ground lower than where the shot was fired, say anywhere within the height of the cliff, somewhere here, then uh, I can't really be certain about that. But yeah, the VFY and VIY, going down and going up respectively, they are supposed to be the same value. They are at its maximum. So for VIY, we've already found the value, which is equal to 19.01782 meters per second. For VFY, hmm, yeah, it's the same thing. I am yet to know what factors can influence the potential need for making those two values different, this and this. Okay, so far for letter B, the process is okay. But then I was wondering why the value didn't double for the final answer. Since what I think is that the golf ball, its duration in the air, we're basically looking for the time. Sorry about that. I'll be asking this. We'll just leave it at that. Never mind. I suppose I overlooked the final answer. I think it's supposed to be this. Okay. Good thing there's a dot there. Um, it would be crazy to think that it's 388,000 seconds. So for the horizontal displacement, that is basically d of x. We have 158.28966. Okay, so we're all good. Let's move to the next problem. So, in order to find Vx, sorry, in order to find the horizontal displacement, we have to solve for two things. Basically, everything that we need for Vx is in this formula. We need to solve for Vx and the time total. So, yeah, it's somehow the same with the way we solved the previous questions, but we are legit just looking for one part if you have to look for the other parts first, even though it's not required. Alright, so we're now at case 3. This is what I was talking about in the previous videos and earlier. I mentioned that in the circumstances where the surface is even, the time going up is equal to the time going down. But now that we are facing questions where there is some sort of a cliff where the projectile was fired, of course, let's say this is the peak. The time that it takes for this projectile to go this path, it naturally takes longer in comparison to if you fire the projectile from here to the highest point before it starts to go down. So let's see. It's been some time since I've solved this kind of problem, but let's see what we can do. Also, if we're looking for the vertical distance, whatever distance we have here from bottom to up, we'll just add that with 800 meters or whatever the height of the cliff is, so that we can find the distance going down, or the vertical distance going down, not the horizontal. So let's see, VFY going up, VIY going down, sorry, VIY going up also. VFY eventually goes 0 meters per second, as well as VIY going down. VFY going down is at its maximum. In regards to the VFY going down and the VIY going up, I've been saying that these values are equal to each other, but right now, as you may just think about it, the momentum of an object that falls in a longer time will have a higher velocity. So these guys are no longer equal. So the horizontal velocity is missing, which is Vx, as you all know. Yeah, since x refers to the x-axis, and the vertical refers to the y-axis. Okay, so now we have the table. The formula in order to solve for the horizontal velocity is said to be Vx is equal to dx over total time. Right? Why is it not here? Okay. So do we have the total horizontal displacement? We don't. I suppose we have to look for the x and y components first. Yeah, so that we can find the VIY and the VFY. VI is said to be 30 meters per second times sine, and then theta is going to be 30 degrees. So 30 sine 30 is equal to 15. Makes sense because sine 30 is basically square root of 1 over 2, or in other words 1 over 2. 1 over 2 times 30 is 15. Hence 15. The unit for VIY is meters per second. Okay, so we found 15 as VIY. How about the VFY? I'm not sure how to solve for that yet, but The angle 30 degrees is also 30 degrees here, but this I'm not sure. But we do have VIY. Let's solve for the distance going up. What's the denominator again? I think it's 2G. Is it? Yes. Okay. VFY is 0. VIY is 15. 2 and then G is negative 9.8 meters per second squared. It's distance, so the unit is going to be meters. So that is the distance going up. So let's just write it. 11.47959. And then the distance going down is simple. So we know that this is 11.4 something, and the distance here is 800 meters. You just find the sum of the two values, which is easily 811.47959. Don't forget the unit. And we have the time. We have to look for the time, I suppose. Yeah, we have to look for the time on these two guys, so that the moment we search for the time for the Vx, we know what the time total is. Okay. So how long does it take to reach the peak? That's the second question. I suppose what we're looking for is the time going up. That's exactly what we're gonna do. So D is equal to VIT plus GT raised to 2 over 2. Let's try this formula. We know the distance. We know what VI is, 15. What is the time? That is the missing one. G is negative 9.8. What is the time again? Jeez, we need more space. Alright, so wait, I don't have a good feeling about this. Let's scrap this idea for a while. Let's use the other formula. But no, there's no time involved in this formula. Let's try gravitational acceleration. Yes, this is more like it. Vf is 0. Vi is 15. Time total is unknown. With that in mind, negative 15 meters per second divided by negative 9.8 meters per second squared. What is the answer? Okay, so this is the time going up. So I guess we solved letter B already. We haven't solved letter A, but we found letter B already, I suppose. Time going down is supposed to be bigger than this value. We still have to find how much time it takes for the projectile to travel this region. So I wonder what to do. We do have the distance. But we don't have the Fy. Let's try to calculate for VFY such that we already have the distance. Okay, so VFY is missing. Distance is 811.47959 meters. VFY raised to 2 minus, what is VIY? It's 0. Well, we can just disregard that. Put 2 times G. G is going down. The gravity is positive, so 9.8 meters per second squared. Multiply both sides by the 19.6. And the VFY raised to 2 is going to be equal to 15,904.99996. Find the square root. VFY is 126.11503 meters per second. Sheesh, I didn't write the units. Okay. Wait, this is not the final answer yet, so I'm not writing it in brown. Okay, that's a lot. The velocity going down is so big compared to VIY going up. Well, understandably, because the distance, the cliff, is 800 meters. And if you think about it, the distance going up was only 11 meters. Compare that to 800 meters. So yeah, it's kind of fair. 126.11502. Well, let's just say 3 meters per second. Okay, so our only problem is the time value. Not sure why we haven't solved it yet, but wait, we already found the time going up. The time going down is missing, so what formula do we utilize? Let's try this formula. G is equal to VF minus VI over total time going down. So the gravity of going down is 9.8 meters per second squared. Vf is, well, the Vfy is 126.11503 meters per second. Viy is equal to what? 0. So what is the time total going down? So 126.11503 divided by 9.8 is equal to 12.86888 seconds. So if you compute for the sum of going up and going down time values, the answer is going to be 14.39949. Okay, so we found the time total. I'll just rewrite the formula for dx, the total horizontal displacement. So Vx is what? We haven't found it yet. Vix is equal to Vi cosine theta. What Vix do we use? Oh wait, never mind. That's what we're looking for. Vi is 30. Then cosine 30 degrees. So we have 15 square root of 3, or just 25.98076 meters per second. Okay, so we know that Vix is equal to Vx, so yeah, we'll use that. Let's just write 15 square root of 3. It's a lot easier to write it that way. And the unit is meters per second. The total time is 14.39949 seconds. So what is the answer? We have 374.10972 meters. Finally, all of that computation just for the total horizontal velocity, and I hope it's correct. Let's see, what's the answer? 374. Huh. What the heck? Yeah, we found we found it, but then wait, what's wrong? Why is it? What is horizontal velocity? How is it Vix? Oh wait, I'm so sorry. In letter A, we are supposed to look for the velocity value, not the total horizontal displacement. There's a difference. Shoot, I wasn't reading in the instructions. Well, lesson learned. The total horizontal velocity is basically Vix. Why is it Vix in particular? X corresponds to horizontal, Y corresponds to vertical. So for Vix, this is what we're looking for letter A. Letter B, how long does it take to reach the peak? That is this value, 1.53061 seconds. Let's see if it's correct. 1.53061, yes, that is correct. How How about letter C? What is the vertical displacement from the initial position to the peak? Vertical displacement. If the horizontal displacement is dx, then the vertical is going to be, well, the distance going up, I suppose. And that is d going up. It's this one. Let's see if we got it correct. If we got it right. So C is 11.47959. 11.47959. Yes, that is correct. D going up, that is, the vertical displacement can also be abbreviated as dy. So if dx is the horizontal displacement, dy is the vertical displacement. It's good to note that. Okay, so dx is equal to horizontal displacement. dy is the vertical displacement. The units are both in meters, ideally. Let's see letter D. How long will it take for the cannonball from the peak to reach the ground? So from the peak to reach the ground, this is not the time total. We are looking for the time from the peak until it reaches the ground. So that is time going down. We already solved for it a while ago. Where is that? T going down. It's this one. $12.86888. Let's see if we have the same answer. There, 12.86888 seconds. And the dy. What is a dy? Wait. So the distance was calculated, like the total distance going down. Sorry, no. The total distance going down is basically the same as the total distance in the vertical aspect. If you see the graph, so from here to down, it's just the same distance as this. Yeah, it's just this. So yeah, we found the distance anyways. It's 111 point something. Where is that? Oh yeah, it's over there. So next question. What will be the velocity and angle at the time of impact? Okay, so the angle we haven't solved for that yet, but the velocity at the time of impact, that is, in other words, the VFY going down. So we already know that value. It's said to be this. And I'll just highlight. Okay, so 126.115 something. Yeah, it's over there. How about the angle? I'm not sure. Well, let's use this formula. It's been some time since I've solved these kinds of problems, and I'm glad I still understand how to solve them somehow. Tan theta. Okay, so why do we use tan theta? In the context of SOHCAHTOA, tan is equal to opposite over adjacent. So wait, what is the value again? Okay, so tan theta is equal to VFY over VFX. Wait, did I get it right? It's only Vx. VFY and VF and VX. We're going to use arctangent. We do know what the angle is going up, so that is 30 degrees. And then VFY is what? It's 126.11503. And then the V of X is what? (25.98076), or just 15 times the square root of 3. This is meters per second. How do we do this again? Oh wait, no. I don't think we use the degree. It's just theta, so angle theta is equal to the arctangent of this entire fraction. So, what does the calculator say? We have 78.35944. And then since this is angle, I believe these meters per seconds units cancel, so we put angle instead. We put a degrees sign. So it's 78.35944. Where do we write that? It's this angle over here. Oops. So as you can see, the angle here and the angle here, they're different. Let's see if we got it. Okay, yes, 78 point something. Okay, so what is the range? Well, I think we did just calculate for it. It's this one. I believe the range is another word for the total horizontal displacement. Let's see. It's VF. Seems suspicious. What is the range? Is it dx or VF? I don't seem to have any notes for that anymore, which is awkward. Okay, I'm not sure what's wrong with this. Let's search. Is range also known as horizontal displacement projectile? The range is the horizontal displacement of the projectile at the end of its motion. Okay. Yeah, I think that's dx. But why did we find for VF? What is that? Either way, let's calculate for it. VF. So the formula is, well, the Pythagorean theorem. Such that a raised to 2 is the VFY. And what is the B? It's 25 something. VIX 25.98076. What is V of X? Again, 25.98076. So the answer is said to be 128.76335. What is the unit? Meters per second, I suppose. But what exactly is that value? What's the name for the VF? It's associated with being the hypotenuse, since the C variable is usually the hypotenuse. Okay, so I'll be researching more on that. But in the meantime, let's celebrate. Let's do number 2. Yeah, we still have a lot more to do. But in the meantime, kindly skip this part. I'll just be right back.